taking a look at something called Kramer's rule. Now, as we move in through good stuff for algebra, there are a lot of other procedures and rules and methods for doing things. This is one of them. Now, this can be a little on the tough side, depending upon what you're working with. But this is a lot easier than actually going through doing elimination or substitution and manually going through and solving. There is another method that we'll take a look at a little bit later on, but it's all going to use this idea of matrices and the graphing calculator. So, granted I've got this here, but the piece that I want to make sure that you put into your little books and have is the following. So I'm going to give you a few minutes, and I want you to make sure that you have this in your little book, because you are going to need it in order to figure it out. All right. Now that you got this, we're going to take the time and we're going to go through an example of this. So, we are going to use Kramer's rule to solve the systems of equations. So, on your graphing calculator, now I would recommend always going through and setting up your matrices first. Matrix A, matrix B, matrix C. So now A I had listed as E, B, F, and D. So I've got E and B, F and D. Just tells you where to go. Same thing with matrix B. Matrix B was simply going to be A, E, C, and F. So I got A, E, C, and F. And then the last matrix is always going to be the coefficient matrix, the numbers out in front. 3, 2, 4, negative 3, 3, 2, 4, negative 3. So really the only tricky ones to come up with are matrix A and B. Done. On, and as usual, reset the calculator. Second to plus, 7, 1, 2. Whoa. Second plus 7, 2. Good. All right. So go to second matrix. We want to edit A, so we go over. Boring you back there? So, I'm going to edit A, so put in matrix A. 2 by 2. And then we just put the numbers in. Negative 1, 2, 10, 3. Bam. Where? What? Oh, my 3 is supposed to be negative? Okay. Negative 3. Sometimes it doesn't take. There we go. So, once you've got matrix A in, you can press second. Mode button, that'll quit. So take you out of it. Then second. X to the negative 1 goes back into the matrix mode. I know, it's kind of a goofy, especially with that operating system where you got to quit and bring it back in, but that's it works the best. So now we're going to go on edit, and we are going to create matrix B. So I got my edit selected, matrix B selected, and I press enter. Now matrix B is a 2 by 2 matrix. Put in 2, 2, and then we put the numbers in for matrix B that we identified. 3 enter, 1 enter, 4 enter, and 10. Enter. Everybody with me so far? Anybody having problems putting it in right now? course, you actually have to put it in. So, next thing we got to do, we need to put in the last matrix, matrix C, so we get second, we hit quit. Second, go to matrix again, go over edit, go down to C. Where are you at? Just hit second, quit again. It'll pull you out of it. Arrow key over to edit. And then go down to where it says C. So your screen should look like what I've got up here. So you got edit, and now you see, now you press enter and you put in it 2x2 matrix, 3, 2, 4, -3, enter, second, quit. Now, I hate to tell you guys this, but that was the roughest part. Yeah. If you want to actually go and calculate it out manually, that's rough. We've done the hardest part, putting those 3 matrices in. Okay? So, next part. What we need to do is find the determinant of each matrix. We've done this before. Okay? So, get this back up here again. So I hit second matrix. We have to go to math, right? Because that's where we find the determinant. So we go to math. We hit determinant. Second matrix. Which one do we want to do the matrix or the determinant of first? A. So we select A. And so I see this on my screen, and I press enter. And it tells me it's -17. Write it down. And then you repeat the pattern again with matrix B and C. So, for matrix, okay, so for matrix B, here we go. Ready, Noah? Okay, so did you get matrix B taken care of? Okay, so now we're going to hit second key. Then we hit that X to the -1, so we get into our matrix again, right? Then we go over to where it says math. DET is on there, so we hit enter. And which one do we want the determinant of now? We already did A. B. So we go second, matrix. Scroll down to where B is highlighted. We press enter. Good. And now I got 34. Which is what I need. Write it down. Okay. Good. I hope everybody got 34. So let's go do C. Okay. Then, second. Second, go back in the matrix, and now I want to do the exact same thing for C. Should come out to be -17. Okay. So we've got our 3 determinants now. Got that, that, and that. Okay, this was kind of difficult, but not too bad. The next one, you actually have to do a mathematical calculation. Now, as we look at this, if I go back to here, it says that X is equal to matrix A, determinant of matrix A divided by the determinant of matrix C. Y is equal to the determinant of matrix B divided by the determinant of matrix C. So, I get over here, what was the determinant of matrix A? Negative 17. Divided by the determinant of C. What was C? Negative 17. X is equal to 1. Determinant of B was what? 34. What's the determinant of C? 17. So Y is equal to negative 2. Huh? Those are the answers. Okay? Now, it is not difficult to deal with. Well, what's difficult to deal with is putting it into the graphing calculator. That's where you guys got problems. Dealing with that calculator, which isn't all that bad. It's really identify your three matrices. Okay? Calculate the determinant of those three matrices. And then divide. A over C and B over C. Okay? So, what I'm going to do now is I want you to go through, I'm going to give you about 5 minutes to do this here. You'll be able to do it in 5, probably less. But I'm going to give you 5 minutes, and I want you to go through and calculate out X and Y using Kramer's rule. Okay? Did you write down the steps? Cool. So, I'll give you 5 minutes, starting now. Okay, so I'm going to go and give it a whirl and set it up. Now, mind you, I am not going to go through and try and do this by myself without looking at the things. I've got the notes sitting here so that I can figure out where does A go, where does B go, where does C go. That's why I told you that you need to have this down in your little books. So, here we go. So, for matrix A has to be EBFD. So that is going to be 3, 2, 7, and 8. Do you agree with me for matrix A? Okay. So now for matrix B is going to be AE, so that's going to be 2, 3, and then it's going to be 3, 7. Y'all in agreement for me there? Huh? Good. Good. C. 2, 2, 3, 8. Okay. So now that I've got those identified, I'm going to go back to my calculator. Second matrix, and I am going to edit out A. So now it's still a 2 by 2, and my A is going to have, let's see, it's going to be 3, 2, 7, 8. Okay. Second quit. Second get into my matrix again, and now I want to edit out matrix B. So I go to B. Still again a 2 by 2. So now it's going to be 2, enter, 3, enter, 3, enter, 7, enter. Okay. My matrix is in. Second quit. Second matrix, go back in, edit out. Whoops. Edit out C. So now I'm going to edit C. Again, it's a 2 by 2 matrix. And so we end up with 2, enter, 2, enter, 3, enter, and 8, enter. So I've got it all in there. Second quit. Now I want the determinants of these three, correct? So we go second, matrix, math, determinant, second, matrix, A, enter. So the determinant for this one is going to be 10. So matrix A's determinant is 10. Okay. Same thing again. I want to do the determinant for B now. So I go second matrix, math, determinant, second matrix, D, enter, and I get a determinant of 5. So here I've got 5. So go back to this, and now I'm going to need the determinant for C. So second matrix, math, determinant, second matrix, let's see, go down to C, determinant, enter, and I end up with 10. Okay, so now it's A divided by C, that's X, right? So X is going to be equal to 10 divided by 10, so X is equal to 1. Y. Y is equal to B over C, so that's going to be 5 over 10, so Y is equal to 1/2. That's it. Huh? 2.5, yes, but 1 over, it has to be half. So that's what this is. Okay. Now, if you've done the elimination with this, it's quite nasty. If you sit there and try and do the substitution, it's equally as challenging. Yes. So, this is drop dead simple. Now, we're going to kind of continue on here with this for the next stage. Now, this is the application of it. This is what you've got once you actually do it. Now, if D is equal to, does not equal 0, you're going to get a solution. When we were going through and doing this here, my D, okay, the determinant in the denominator, the C, turned out to be 10. When I was able to divide each one of these by 10, it worked. So if I am dealing with this here, if none of the determinants are 0, we're great. If I have a determinant that is 0, and it's in the denominator, there is no solution. Okay? If I have zeros for the determinant, and I've got them in the denominator and the numerator, if the numerator is at least, if one of them is 0, they are going to end up being parallel, and there's going to be, or I should say the same line, sorry, and they've got an infinite number of solutions. So, we are going to go and take a look at Cramer's rule for these two. So, what is matrix A? I need my matrices again, A, B, and C. So let's get them set up. So A turns out to be matrix E, B, F, D, right? So that's going to be 5 and 8, and then it's going to be 2 and 2, correct? Does that make sense? Okay. By the way, as you look at this, you'll notice that when we're doing the first variable, which is really the x, we deal with these numbers switched. What about for B? Well, for B, it's going to end up being A and C, which is 3 and 3, and 5 and 8. Last matrix is going to end up being 3, 2, 3, 2. Okay. So, calculator time. Let's go. And like I said, putting this stuff into the matrices is the hardest part of the whole darn thing. Okay. So, enter, enter, 5, enter, 2, 8, 2. Second quits, second matrix, Oops, clear that out. Second matrix. Go to edit B. 2 by 2 yet still. So I end up having 3, 5, 3, 8. Second quit. Matrix, edit. 2 by 2 again. And 3, 2, 3, 2. Second quit. So now that I've got that information, I can come up with my determinants. So, matrix, math, determinant, A, -6. Okay. Second matrix, math, determinant, B. That turns out to be 9. Second matrix, math, determinant, second matrix, oops, I said second matrix, please, thank you. 3, enter. And now I end up with a 0. Okay. So, that means it's -6. Oops, sorry. That means I'm going to get -6 over 0. Actually, I should just write it this way. -6 over 0, -9 over 0. Division by 0 is what? Impossible. It's undefined. It's not 0. It's just undefined. Now, what I want you to take a look at, we've talked about this idea before. When we are dealing with the coefficients, slope is equal to negative b over a. Okay? So if this is a and that's b, are these two going to have exactly the same slope? If my a's are both 3 and my b's are both 2, are they going to have the same slope? Yes. When you have something that has the same slope, they're either going to be the same line or they're going to be parallel, correct? If these two are different, these are the y-intercepts where it goes through the y-axis at, they're at different places, these have to be parallel lines. Okay? So what we've done here is we've just identified that there isn't going to be a solution to this. Now, do you always have to go through and do the math? No. If you can recognize that, hey, those are the same, that's different, you have to recognize that this is a parallel line. I don't have to go through all this. So what about the next one? Is there a shortcut to that? Well, are they the same? I got 3, 2. Do I have 3 and 2 here? The answer is no. So set up the matrix. So for A, matrix is going to be 5, 10, and 2, 4. Matrix B is going to be, let's see again, that's going to be 3, 6, 5, 10. Matrix C is going to just simply be 3, 2, 6, and 4. So, put the matrices in. Second matrix. Edit out A. Enter, enter. We end up with 5, 2, 10, 4. Okay. Second quit. Second matrix. We're going to edit out B. Enter, enter. So 3, 5, 6, 10. Enter. Second quit. Second matrix. edit C, 2 by 2 again, and we end up with 3, 2, 6, 4. Second quit. So now that I've got the matrices in, I need to go through, calculate out what the determinants are going to be. So, second matrix, sorry, second matrix, there we go, calculate out determinant, 0. Second matrix, determinant, 0. What do I get for C when you do that one? 0. So, they're all zeros. These two lines are multiples of each other. In other words, these are exactly the same line. There is going to be an infinite number of solutions. So what's the trick to see here? 3, 2, and 5. If I multiply 5 by 2, I get 10. If I take 2 by 2, I get 4. 3 by 6, 2. They're doubles. If you run into a situation where you are looking at the equations and they are multiples of each other, you don't have to go through and do it. Why? Because you know exactly what is going to happen. They are going to be the same line, and there is going to be an infinite number of solutions. Those are the catches. Okay? If they're multiples of each other and those are multiple, infinite solutions. If these are multiples, these are different, parallel lines. If you can see that, you are going to make life a lot easier for yourself. Okay? So, I'm going to stop there, and the assignment is going to be due at the end of class tomorrow.